So this is what we discussed in the last session, polynomial division. How do you divide one polynomial by another polynomial? Okay. ये हमने long division method इसके लिए सीखा, ठीक है? We went through this process a few times on different examples. And then we said, when we do that division, we've got this relationship between the dividend, divisor, quotient, and remainder. This is how these things are related to each other. Okay. Let me actually just copy this as well because it's going to be helpful when we discuss the remainder theorem a bit. But anyway, we discussed these examples. हमने सारे cases किए थे. You have to be a bit careful when you have any term missing in the dividend or the divisor. For example, this example that we did, we had the x squared term missing. So in place of that, we had to put 0x squared here. Okay, so that we have like terms in the same vertical line. Otherwise, you end up having a lot of confusion when you're doing the plus minus thing at the end. So make sure that you do this whenever you have a term missing from the dividend or even sometimes in the divisor, whichever term is missing, in place of that, you put a term with 0 coefficient. So here you could say this is 0x squared in the middle here. Okay, and that will save you from those confusion, and then you can just follow the standard process. It will work every time. All right, so this is what we discussed in the last session. We discussed how to divide polynomials. Now today what we want to do is we want to discuss this concept called the remainder theorem. And there's actually a variation of this. That's called the factor theorem. So that's actually just a special case of remainder theorem. That's not something new, but you should be familiar with the name because the examiner sometimes uses this name, factor theorem. So you should be familiar with the terminology for that as well. Now, let me take you back to this example that we did in the last session, where we divided this polynomial by a linear divisor, which was x minus 2. So we had this polynomial, 2x cubed minus 14x plus 16, and we divided this polynomial by x minus 2. Why? Because we had to find the quotient and the remainder. हमें ये दो चीजें find करनी थी, quotient find करना था, remainder find करना था. So we did that division and we found those quotient and remainder. Now let's say we did not need the quotient and we only needed the remainder. All right, so let's actually change this question statement a little. Let's say it only said find the remainder when 2x minus cube minus 14x plus 16 is divided by x minus 2. Now, one way of doing this is to follow the same process that we did in the last session, that you divide by x minus 2, you follow through the whole process, and at the end, you get this thing. That is your remainder. That's one way of doing this, okay? But you can also use this theorem called remainder theorem to find the remainder directly without actually having to do this whole division process. All right, and that's what you want to do right now. How can you find the remainder directly without dividing this whole thing and without doing all of this long division process? How can you find the remainder, this number 4, directly? Okay, that's what the remainder theorem is going to be used for. Now, there's a condition for this. Let me just add this here in the heading. This remainder theorem only works for linear divisors. Okay, so the expression that you're dividing by that has to be linear. So that's a limitation of this theorem. So you can only use this for linear divisors. Otherwise, you can't use this. Okay. All right. So I was saying you can only use this theorem for linear divisors. Otherwise, you cannot use it. Now, how exactly does this process work? Let's quickly try to get a quick intuition behind this, and then we'll discuss this theorem. I told you about this identity earlier, how the dividend divisor, quotient, and the remainder are related to each other. Now, if I were to just rearrange this a little, such that I multiply this divisor on the other side, what is that going to give me? On the left side, I've got the dividend. On the right side, I would have the quotient multiplied by the divisor. And when the divisor gets multiplied with this term, the divisor in the numerator and the denominator, they get cancelled, and we're only left with the remainder there. So this is another way of writing that same identity, that the dividend equals quotient multiplied by the divisor plus the remainder. Now let me write these things here. My पास dividend था यहाँ पे, let's write that there, and also the remainder, the quotient and the divisor. Dividend is 2x cubed minus 14x. 2x cubed minus 14x plus 16. That was the dividend. Now, once I've done that whole division process, this dividend can be written as quotient multiplied by the divisor. The quotient is 2x squared plus 4x minus 6. 2x squared plus 4x minus 6. Multiplied by the divisor was x minus 2. Plus the remainder is 4. So what has happened here is that I've written this dividend in this form as quotient into divisor plus remainder. These are both identical. What I have on the left side and what I have on the right side, they're both identical. Okay, so it's just another way of writing this. The right side पे आपके पास आ रहा है. This is just another way of writing this thing. If you were to expand this whole thing, you could try this as an exercise. If you were to expand this and simplify this, you're going to get 2x cubed minus 14x plus 16 back. वही चीज आपको वापस मिल जाएगी. Okay, it's not something different. It's the same thing, just written in a different form. Now, why is that relevant? Well, you've got quotient into divisor. Now, if you were to use a trick here and you say, let's put a value of x here such that this thing becomes 0. So again, keep the end in mind. What do we want? We want the remainder. We want to find the remainder. Remainder is this thing that's 4. So if I can somehow get rid of this whole thing, I would only be left with the remainder. One way to get rid of this whole thing is that you put a value of x that makes this bracket 0. How does that work? You could make x minus 2 equal to 0. For that, you would need x equal to 2. So if you were to input x equals 2 in this polynomial, what would happen would be that this whole thing becomes 0, right? Because 0 multiplied by anything is going to be 0. And you're only going to be left with 4 here, which is your remainder. All right. Now, how do we use that? Because yahan pe to we have already found the quotient and the remainder and the divisor. How does this help? Since we already know the remainder here, the remainder is 4. So we already know the remainder. What's the point of doing all of this? Well, this thing that you have on the left side, this is the same polynomial. If we were to input x equal to 2 here, where's that x equals 2 coming from? By making this bracket 0. So when you make this bracket 0, the value of x that you get from there is x equals 2. If you were to input x equals 2 in this polynomial directly, that is going to give you the remainder without having to go through this whole process. So without actually doing the division, you can find the remainder directly. How? Let's input x equals 2 here. That gives you 2 into 2 cube minus 14 into 2 plus 16. Let's simplify this, and that gives you 16 minus 28 plus 16. That's 32 minus 28. And you end up with 4, which is exactly what the remainder is. So what are we doing? We're saying we've got this dividend. All we've got to do is this divisor that we have, x minus 2, you put this equal to 0 and see what value of x you get from that. If you were to just input this value of x in the dividend, you will get the remainder directly. You don't have to follow this whole process. You can get the remainder directly. Okay, I hope that makes sense. Now I'll quickly summarize all of that. This is just the background of how you come up with this the very first time. Now let me write down what the remainder theorem, how the remainder theorem looks. Let me write down a statement for this that you can keep in mind, and you can use in situations like this. So remainder theorem. You have to keep in mind that it only works for linear divisor. It doesn't work otherwise. The condition is the divisor has to be linear. If there's a polynomial, let's say p of x, that's the name that we're giving to this polynomial, is divided by a linear divisor, for example, x minus a, the remainder will be p of a. p of a का मतलब क्या है? That you're basically inputting this value a in the polynomial. That's all that it means. All right, let's take an example. Let's say we've got this polynomial p of x, which is, I don't know, let's say 3x cubed plus 4x squared minus 2x plus 7. I've got this polynomial. And what I want to find is, what is the remainder? What is the remainder when p of x is divided by, let's say, x minus 2. Let's just divide it by x minus 2. Okay. Now, how do you use the remainder theorem? All you've got to do is put this divisor equal to 0. X minus 2 equal to 0. What value do we get from this? You get x equals 2. And now what you do is you put this value in this polynomial. You say, let's input x equals 2 here. So that's p of 2. And you evaluate this, you get 3 into 2 cubed plus 4 into 2 squared minus 2 into 2 plus 7. Now you can evaluate this and see what you get. The number that you get from this is going to be the remainder. All right, can somebody evaluate this and let me know what this number turns out to be? Anyone evaluate this?
Sir, I think 43 आता है.
43. Okay.
Yes, sir, 43.
All right, so this is your remainder. So if you were to divide this polynomial by x minus 2, the remainder would be 43. So now you don't have to follow that whole long division process. You can actually just figure this out directly using this remainder theorem. And the condition is the divisor has to be linear. Okay, the divisor has to be linear. That's a condition. All right. Now, let me just write down some examples. For instance, if you have a divisor of this form, x minus 5. If the divisor is 5, what value of x are we going to input in the polynomial for finding the remainder?
5.
We're going to put this equal to 0, x minus 5 equals 0. And that is going to give us x equals 5. You'll input this in the polynomial, you'll find p of 5, that will be the remainder. Okay. Similarly, if you had another divisor, let's say x plus 2, what would you do? You would put this equal to 0. That gives you x equals minus 2. You input this in the polynomial, p of minus 2 would be your remainder. If you had something else like 3x plus 5, again, what you do is you put this equal to 0, 3x plus 5 equal to 0. That gives you x equals minus 5 over 3. Put this in the polynomial, and that is minus 5 over 3. You input minus 5 over 3 in the polynomial, evaluate that, simplify that. The result that you get is going to be a remainder. So whatever is the divisor, you put that equal to 0, the value of x that you get, you put that in the polynomial, and that's going to give you the remainder. All right?
Sir?
Yes.
Sir, but this is for linear numbers only, right?
For linear divisors, so
Yes.
anything of this form, anything of
Okay.
mx plus c form, it works for anything like this.
Okay,
But
sir.
if the divisor is quadratic, then you have to do the long division process, and then it doesn't work.
Okay, sir.
So it has to be linear. All right. Achha. Now, the next thing that we want to discuss is what are factors? ठीक है, इसी से हमारे पास एक आता है factor theorem भी. That's just a special case of remainder theorem. So we are familiar with factors with reference to numbers, right? For instance, we know that 4 is a factor of 72. Why is that a factor? Why do we say 4 is a factor of 72? Because 72 or because 4 divides 72 completely. You get no remainder when you divide 72 by 4. So if you were to do this division, 72 over 4, let's see what we get from that. 72 divided by 4, We multiply 4 by 1, that gives us 4 times 1, which is 4. Change the signs, you've got minus sign here. And that gives you 3, 2. Then 4 times 8 is going to give you 32. When you do the subtraction, you figure out that the remainder is 0. Now, since the remainder is 0, we say that 4 is a factor of 72. So if one thing is divided by another, that means, and the remainder turns out to be 0, that means the divisor that you've got there, that is a factor. That's a factor of 72. Now, not only is 4 a factor, the quotient is also a factor, because 4 multiplied by 18, that is going to give you 72. So 18 also divides 72 completely. The quotient that you get in this case is also going to be a factor. All right. So when the remainder turns out to be 0 in this division process, you should know that the divisor and the quotient, they are both factors. So factor kya hota hai? If the remainder equals 0 in a division process, that means the divisor, this number here, is a factor of the dividend, and the quotient is also a factor. Okay, they're both going to be factors. Make sense? Any problems? All right, so let's use this here. Let's say first we want to prove or show that this polynomial 2x cubed minus 14x plus 12, or maybe the other way around, show that x minus 2.
Sir, could you check the waiting rooms?
Okay, sure. There's no one here. Was it Isha?
Sir, Isha and Iman.
Isha is already here, I think now. Iman is also here. Okay. Achha, show that x minus 2 is a factor. So that x minus 2 is a factor of this polynomial. Let's say this is what we want to do. We want to prove that this is a factor. Now, how do you do this? We just discussed the definition of a factor. What is a factor? If you were to divide this polynomial by x minus 2, if the remainder turns out to be 0, then x minus 2 would be a factor of this polynomial. So how can you prove this? One way of doing this is that you do the long division process. When you do that long division process, at the end, you'll get the remainder. If the remainder is 0, you say it's a factor. But is there a quicker way of finding the remainder? We just discussed that. You can actually find remainder using the remainder theorem. Why? Because this is a linear factor. This is a linear divisor. Since it's a linear divisor, we can use the remainder theorem. Now, let's write down the polynomial. Let's call this p of x. The polynomial is 2x cubed minus 14x plus 12. This is the polynomial. X minus 2 is the divisor. Now, how do you find the remainder when this polynomial is divided by x minus 2? What we do is we put x minus 2 equal to 0. What value of x do we get from this? We get x equals 2, and you put x equals 2 in this polynomial. That gives us p of 2 equal to 2 into 2 cube minus 14 into 2 plus 12. Okay, that's the that's what we get when you input x equals 2 in this polynomial. Now let's simplify this and see what we get. We get 16 minus 28 plus 12. What's that? That's okay, let me just write that down. 16 minus 28 plus 12, and this turns out to be 0. 0 is the remainder, right? You input 2 in the polynomial, the result turns out to be 0. Now, since this is the remainder and the remainder is 0, you say x minus 2 is a factor of that polynomial. Since remainder is 0, since remainder is equal to 0, x minus 2 is a factor of that polynomial. Make sense? All right, I think I'll just stop here for a minute. In case you have any questions, let me know before we go on. Any questions? Does this make sense to everyone? You can also write in the chat box if you don't want to speak up. You have the chat box for this as well. Right there. No problem? Okay, good. Chale. Let's discuss how to factorize polynomials then. Okay? So this is what we do if we have to prove that something is a factor of a polynomial. What we do is we find the remainder. We could use that. We could find that using the remainder theorem, or we could find that using the log division method as well. That's your choice. But since it's a linear divisor, it's always quicker to find the remainders using the remainder theorem. Achha, by the way, this thing that we have done here, where the remainder has turned out to be 0, is a special case of remainder theorem and is known as the factor theorem. So the factor theorem basically says if you divide something by a factor, if x minus 2 was a factor, then p of 2 would be equal to 0. What does that mean? If you were to input x equals 2 in the polynomial, the result would turn out to be 0. इसको factor theorem भी कहते हैं, right? So it's a special case of remainder theorem. In the remainder theorem, when the remainder is equal to 0, the remainder theorem basically becomes the factor theorem. Okay, so it's not something different from that. It's just the same thing. Just call that special case when the remainder turns out to be 0 to be the factor theorem. Okay, so just a name that you should also be familiar with. Sometimes they use that terminology in the exam, that use factor theorem to do something. Essentially, you just have to use the remainder theorem. Okay, they mean the same thing there. Achha, let's take another example. Let's take, in fact, let's take the same example. इसको मैं थोड़ा सा modify कर लेता हूँ. Yeah, so divide 2x cube minus 14x plus 12. ये division पहले की तो नहीं है? Same division. Okay, no, that was different. Okay, 2x cube minus, or was it different? Slightly different. Okay, 2x cube minus 14x plus 12. This is polynomial. Divide this polynomial by, let's say, use another factor, if I can find that. Okay, let's divide it by 2x minus 2, or let's say x minus 1. And use your division process to factorize this polynomial. Which polynomial? This is the polynomial that we're trying to factorize. इसको हम p of x कह लेते हैं. ठीक है? So what they're saying is divide 2x cubed minus 14x plus 12 by x minus 1. Division करनी है. So basically you have to use the long division method. Find the remainder and the quotient, and then use that to somehow factorize this thing. So let's try this, and then we'll try to understand how we can do this factorization. Now, before we actually do this, you have to be a bit careful before writing this. One of these terms is missing, right? The x squared term is missing. So you are going to be writing it like this. Let's say this is 2x cubed plus 0x squared minus 14x plus 12. Okay, that's the polynomial that you've got. You need to divide it by x minus 1. How do you start the division process? What do you multiply x by to get 2x cubed? You multiply it by 2x squared. All right. X multiplied by 2x squared is going to give you 2x cubed. And now you multiply 2x squared with this whole thing. That gives you 2x cubed minus 2x squared. And now you change the signs and do the subtraction. This becomes minus, this becomes plus. 2x cubed minus 2x cubed, that is cancelled. 0 plus 2, that is 2x squared. Bring everything down here as well, minus 14x plus 12. And now look at the next term. What do you multiply x by to get 2x squared? You'll have to multiply this by 2x. All right. Now you multiply 2x with this thing. What does that give you? That gives you 2x squared minus 2x. All right, now we change the signs again. Put this straight line. And now change this negative, this to positive, this gets cancelled. And we have minus 14x plus 2x. That becomes minus 12x plus 12. Now, what do we multiply x by to get minus 12x? We have to multiply it by minus 12. Okay? And now minus 12 into this whole thing, let's see what that gives us. Minus 12x plus 12. Change the signs. Plus, minus, this gets cancelled, this gets cancelled. And we're left with 0 at the end. So the remainder turns out to be 0. What does that mean? If the remainder is 0, that means this divisor is a factor. Usne bataya nahi tha aapko, but you know now that this thing is a factor because the remainder is 0. All right. So that polynomial that we had at the top, it has one factor, which is, if you have to write it like this, 2x minus 2x cubed minus 14x plus 12. This was the polynomial. So one factor that we got for this polynomial is x minus 1. This is a factor. But remember what we said just a few minutes ago. We said if remainder is 0, divisor is a factor. So yeah, that's okay. The divisor is a factor. But there's another thing. The quotient is also a factor. The quotient that you've got there, that is also going to be a factor. So one factor is x minus 1. The other factor is 2x squared plus 2x minus 12. This is the factorization of this thing. Okay. Now, once you're done with this factorization, you don't have to just stop there right now. You have to also figure out, can you factorize this further? Can you do middle term breaking here and convert it to linear factors somehow? Think about it. 2 into 12, that's minus 24. So how can we get minus 24 in the middle? We could use 6 and 4. Yeah, that's going to work. So we could do the middle term breaking thing here. We can say this is x minus 1 into 2x squared plus 6x minus 4x minus 12. And now we get factors from this, x minus 1 into 2x into x plus 3 minus 4 into x plus 3. And now we've got this factorization, x minus 1 into 2x minus 4 into x plus 3. These are the factors that we've got for this polynomial. हमने उसको factorize कर लिया polynomial. Okay? This is how factorization works. You'll have one factor. In this case, we divided by x minus 1 and figured out that x minus 1 was one factor. If you know one factor, how can you find the other factors? You just divide by that. You get the quotient. Quotient is going to give you the other factor. All right. And then you just multiply those two. And that results in the factorization. Is this process clear to everyone? Any problems with this? Any problems, anyone? We have covered a major chunk of this topic in terms of concepts. Now, in the next 30 minutes or so that we've got, we're going to be doing some practice questions. We're not going to discuss anything new now in terms of concepts. So let me know if there are any problems so we can address them right now, because now we want to start doing some practice questions from the worksheet that I posted. I hope I've posted that already. Let me just check this if I haven't. Yeah, I have posted the worksheet already, and you've got questions posted there as well. Please make sure to start doing these questions. You can do the first row completely. Okay, so you've got question numbers written in 3 rows initially. Aapne first row sari kar leni hai before your next class. Now you can do all of that. Okay, first row aap complete kar sakte hain. Please make sure that you do that. Saath saath karna hai, very fayda hoega. Okay, any quick questions before we start doing some questions? Any problems? No? All right, and if there are no problems, let's do some questions from that worksheet. Paper 3, polynomials worksheet. Okay. I'm starting with this question. This is question number 4 from the worksheet. Let me just copy this there. All right. The polynomial x raised to the power 4 plus 3x squared plus a, where a is a constant, is denoted by p of x. So we've got this polynomial. P of x equals x raised to the power 4 plus 3x squared plus a. This is the polynomial. It is given that, gaps बहुत ज़्यादा हुए हैं letters के दरम्यान में. It's x square plus x plus 2. So we are given that x square plus x plus 2 is a factor of p of x. What we need to do is we need to find the value of a and the other quadratic factor of this polynomial. So one factor is given, that's x squared plus x plus 2. We don't know the other factor, that's one thing. And we also do not know the value of a. We need to find the value of a here. What do we do? Any ideas? Can we use the remainder theorem to find the remainder and put that equal to 0? Will that
No,
work
sir.
here? Why not?
So linear नहीं है factor.
So the remainder theorem only works when the divisor is linear. Otherwise, it doesn't work. This is not linear, so the remainder theorem is not going to work. What's the other option that we've got? We'll have to use long division. Okay, so let's use the long division process here to divide this polynomial by x squared plus x plus 2 and see what we get. You'll have to do long division anyway because you also need the other quadratic factors. You'll need the quotient from that long division process. So even if you could use the remainder theorem, you'll have to do long division in any case. Okay, that's going to be required in any case. All right, now let's do this division. So you've got x square, x raised to the power 4 plus, now be careful, the x cube term is missing here. This term is missing, so that's 0x cubed. X raised to the power 4 plus 0x cubed plus 3x squared. And now the x term is also missing, so that's 0x plus a. This is what your polynomial is. All right. And now what we want to do is we want to divide it by x squared plus x plus 2. Okay, that's what you want to do. Divide करना है इसको x squared plus x plus 2 के साथ. Now, how does the long division process work? You start with the first term of the dividend and also of the divisor. So the first term of the dividend is x raised to the power 4, and the first term of the divisor is x squared. What do you have to multiply x squared by to get x raised to the power 4? You have to multiply it by x squared. And now you multiply x squared with this whole thing. What does that give you? That gives you x raised to the power 4 plus x cubed plus 2x squared. All right. Now you change the signs. This becomes minus, minus, minus. This gets cancelled. 0 minus x cubed, that is minus x cubed. 3x squared minus 2x squared, that is plus x squared. Then you have plus 0x plus a. What do you multiply x by to get minus x squared by to get minus x cubed? Now you have to multiply it by minus x. All right. Minus x into this whole thing. That gives you minus x cubed minus x squared minus 2x. Now change the signs again. This becomes plus, and this also becomes plus. This gets cancelled. X squared plus x squared, that is 2x squared. 0x plus 2x, that gives you 2x. Then you have plus a from here. Now let's do the next step. What do you multiply x squared by to get 2x squared? You'll have to multiply it by 2. So you've got plus 2 here. 2 into this whole thing, that is going to give you 2x squared plus 2x plus 4. Again, you change the signs. Minus, minus, minus. This gets cancelled. This also gets cancelled. And you're left with a minus 4. Now, can we go on with the long division process? We can't. We have to stop here because the degree of the remainder is less than the degree of the divisor. We can't go any further than this. we were given that x square plus x plus 2 is a factor. Factor ka kya matlab hota hai? What's the first thing that comes to your mind when you read the word factor? That basically means that the remainder is equal to 0. Now you've done this long division process and you're getting a remainder at the end. This remainder should be equal to 0 for x square plus x plus 2 to be a factor. So we put that remainder equal to 0. What does that give us? That gives us a minus 4 equals 0 and a equals 4. This is the value of a that we're getting. That's one thing that we have to do. Now, we were also asked to find the other quadratic factor of p of x. So one quadratic factor is x squared plus x plus 2. What about the other factor? This quotient is also a factor. So we'll write down here explicitly, because you've been asked about this. You're not just going to leave it like this and assume that the examiner knows that you know that this is the other factor. You have to write it down explicitly. You'll say this is this other quadratic factor is x squared minus x plus 2. This is the other quadratic factor. This is what we were looking for. Makes sense? So if we had to factorize this, we'll factorize this polynomial p of x. We would write it as the factorized form of that polynomial would be x squared plus x plus 2 into x squared minus x plus 2. This is the factorized form of that polynomial. Makes sense to everyone? Any problems with this? Why is this class so silent? Is this all right? Can you guys respond?
जी sir.
Okay. Started raining here. That's good. Okay, chale, let's do another one. This was question number 4 from the worksheet. Let's take another one. Okay, let's try this. This is question number 18 from the worksheet. Let's attempt this one. All right. So we have this polynomial ax cubed plus bx squared plus x plus 3, where a and b are constants. It's denoted by p of x. It's given that 3x plus 1 is a factor of p of x, and that when p of x is divided by x minus 2, the remainder is 21. We need to find the values of a and b. Now, remember what factor means? Factor means that the remainder is equal to 0. So we've got this polynomial, which they are denoting by p of x. P of x equals ax cubed plus bx squared plus x plus 3. This is the polynomial. We're given that 3x plus 1 is a factor. What that means is, when we divide by 3x plus 1, the remainder turns out to be equal to 0. That's one piece of information that we're given. And then we're also given that when p of x is divided by x minus 2, in that case, the remainder is 21. So when it's divided by x minus 2, the remainder turns out to be 21. All right. Now, using this information, we need to find the values of a and b. Now what we can do is we can use the remainder theorem, right? We can, because this is a linear factor and this is also a linear factor. They're both linear factors, so we can use the remainder theorem in both of them, right? So how do we use that? 3x plus 1, you put this equal to 0. 3x plus 1 equal to 0. That gives you x equals minus 1 over 3. And you put this value of x in that polynomial. You find p of minus 1 over 3. You evaluate this thing. In place of x in this polynomial, you put minus 1 over 3 and see what you get. A into minus 1 over 3 whole cube plus b into minus 1 over 3 whole squared plus minus 1 over 3 plus 3. Now, what does this simplify to? Remember, when we take cube of negative numbers, the negative sign stays there. Minus 1 over 3 whole cube, that's going to give us minus 1 over 27 times a. Minus 1 over 3 whole square, that's 1 over 9. So that's 1 over 9 times a. Sorry, b. Minus 1 over 3 plus 3. Now, this is the remainder, right? So we're inputting minus 1 over 3. That is going to give us the remainder. But they've also told us that the remainder is 0. So what we do is we put this equal to 0. Because the remainder has to be 0, right? So we put this whole expression equal to 0. Now we simplify this. What we can do is we can, okay, let's actually add these two first. They're going to give us minus 1 over 27a plus 1 over 9b. 3 minus 1 over 3, that is 8 over 3. And now you can multiply the whole equation by 27 to get rid of the fractions. That's give us minus a plus 3b plus 8 times 9. What's that? That is 72, I think. And from this, we get one equation, which is a minus 3b equals 72. Okay. Now, this is one equation, and we have two unknowns. We can't really find the values of a and b directly from this equation. We'll need some more information. Let's look at the other divisor that we're given. We're also told that when this polynomial is divided by x minus 2, the remainder turns out to be 21. So now from this, what you can do is, using this, what you can do is, you can just input in place of x 2, because x minus 2 equals 0 gives you x equals 2. And now in that polynomial, you input 2 instead of x. So you find p of 2. Let's see what that gives us. A into 2 cubed plus b into 2 squared plus 2 plus 3. And now in this case, we're given that the remainder is 21. We are getting this remainder. So we put this whole thing equal to 21. 21 equals 8a plus 4b plus 5. And that gives us 8a plus 4b equals 21 minus 5, which is 16. We can simplify this, and that gives us 4a plus b equals 4. No, sorry. Something wrong here. Yeah, should have 2 here. 2a plus b equals 4. This is another equation that we've got. Okay, we've got two equations, two unknowns. You can solve them simultaneously and find the values of a and b from that. Okay, let's find these values. We can use any method that we are comfortable with. Let's say, let's make a the subject here. A equals 72 plus 3b. Now you can take this thing there and put in the other equation. What does that give us? That gives us 2 into 72 plus 3b plus b equals 4. Now simplify this. You get 144 plus 6b plus b equals 4. 7b equals minus 140 and b equals minus 20 from this. Put this back in the other equation now, and that's going to give us the corresponding value for a. A equals 72 minus 3 into minus 20, and a turns out to be equal to 72 plus 60, which is 132 in this case.
Sir, A 72
Does
plus
that make sense?
3B.
Oh, sorry, yeah, it's plus 3b. Thank you for that. This is plus 3b. So that becomes 72 minus 60. That's actually 12, not 132. This is 12. The value of a turns out to be 12. This is what we had to find. We had to find the values of a and b. A is equal to 12 and b is equal to minus 20. ये दो values हमें figure out करने थे. Make sense? Any questions? Any questions, anyone?
Sir.
No? Okay, let's do one more example and then we end after that. Let's try question number 3 from the worksheet. Okay, it's a small one. At least that's what the number of marks show us or hint us. Okay, question number 3. Let's try this. There's this polynomial x cube minus 2x plus a is denoted by p of x. P of x equals x cube minus 2x plus a. It's given that x plus 2 is a factor. X plus 2 is a factor of p of x. We need to find the value of a using this. Now, since x plus 2 is a factor, we can use the remainder theorem, right? It's a linear factor. We can just put this equal to 0, x plus 2 equal to 0. That gives us x equals minus 2. So if you were to input x equals minus 2 here, the remainder should be equal to 0 because it's a factor. Factor ka matlab hota hai that the remainder is equal to 0. So that's what we do. We put x equals minus 2 here. P of minus 2, that equals minus 2 whole cube minus 2 into minus 2 plus a. Since the remainder should be 0, we put this equal to 0. That gives us minus 8 plus 4 plus a, and a turns out to be equal to 4 from this. And that was pretty straightforward. A equals 4, the first part. Now the second part says, when a has this value, that means when a is equal to 4, find the quadratic factor of p of x. Okay, so now the polynomial is this, which is x cubed minus 2x plus 4. This is the polynomial. We know that x plus 2 is a factor already. What is the quadratic factor? How do you find that? Anyone other than Josefa? How do you find the quadratic factor? Any ideas? We have a linear factor. We need to find the quadratic factor. How can we find that? Anyone?
Sir, long
Hello.
division.
Long division? How would that help? What do you do after long division?
Sir, wouldn't we get the other factor, the quadratic factor?
Yeah, and where in long division would that be?
The quotient.
The quotient, right? So that's good. We know that x plus 2 is a factor. When we divide this polynomial by x plus 2, we would get a quotient. That quotient would be the other factor of this polynomial. And that's going to turn out to be quadratic because this is cubic, this is linear. So the remaining factor is going to be quadratic. Let's do that division. So we have x cubed. The x squared term is missing, so we have 0x squared in place of that, minus 2x plus 4. We divide it by x plus 2. Now, what do you have to multiply x by to get x cubed? You multiply this by x squared. X squared into this whole thing, that gives us x squared plus 2x. Now change the signs. This becomes minus. Sorry, there's something wrong here. This should have been x cubed, and this should have been x squared. This is x cubed plus 2x squared. Now, when we change the signs, this gets cancelled, and 0 minus 2, that gives us minus 2x squared, minus 2x plus 4. Again, you think, what do you have to multiply x by to get minus 2x squared? You multiply it by minus 2x into this whole thing now. That gives you minus 2x squared minus 4x. Change the signs again. This gets cancelled. Minus 2x plus 4x, that is 2x plus 4. Now, x multiplied by 2 gives you 2x. So you multiply by 2 here. 2 into this whole thing, 2 into x plus 2. That is going to give you 2x plus 4. Change the signs again. Everything gets cancelled. And you have 0 at the end. The remainder is 0. That confirms that your process is correct because x plus 2 was a factor. So remainder should have been 0. What's the quadratic factor now? It's x squared minus 2x plus 2. That is the quadratic factor that we were looking for. यहाँ पे लिख देंगे. Let's say the quadratic factor is x squared minus 2x plus 2. This is the quadratic factor. All right. Any problems with this? Make sense? Okay,
Sir,
so
sir, one question. How do we know we should not factorize the quadratic factor?
yeah, so that's a good question. How do we know if we should factorize this quadratic factor or not? Well, you always try and do that. If it can be factorized, you should factorize it. So can we break the middle term here? Is that possible? Can we do that? Does anything work? It doesn't, right? We can't factorize it. So normally whenever you can break the middle term, you do that. In this case, though, they had asked you for the quadratic factor, right? So you know that you have to leave it as quadratic, right? So you don't even have to think about it. But when they say when they ask you to factorize something, and especially they use the word completely, factorize something completely. So I might show you, let me actually show you some question from here where they ask you to factorize something and they also use the word completely. So when they say something like this, factorize p of x completely. This word completely is mostly a hint that if you're getting a quadratic factor, you can further factorize it and make it linear factors. Okay, so that they generally give you a hint using this word completely. But even if they do not give you any hint, you should always check if you can factorize the quadratic factor further. If you can, you should do that. If not, you can just leave it like that. Okay.
ठीक है sir, thank you.
Anything else? All right, so now please make sure that you attempt those questions from the worksheet. You've got a lot of time now. You've got 3 days, attempt all those questions. In fact, you can actually do the second row as well from this. First row भी कर सकते हैं, second row भी कर सकते हैं equations वाली. जब factorize कर लिया, factorize करने के बाद equation solve करना is pretty straightforward. You just put that equal to 0 or individual factors को 0 से equate कर देते हो. So you can solve the equations as well. Okay. So we are mainly left with this last concept, inequalities. कैसे solve करते हैं cubic polynomials के case के अंदर. That is what we will do in the next session, hopefully, inshallah. But you can do the rest of them. Apart from inequalities, you can complete the whole worksheet. So please use this time well. Try to do as much practice as you can so that you get better at this particular topic as well. जब तक practice नहीं करेंगे, आपको नहीं पता चलेगा कि आपको concept समझ आए हैं कि नहीं आए. ठीक है, खुद से आपने practice करनी है. That is what is going to help. All right, so if there are no further questions, that's it then. I'll see you again on Monday. Allah Hafiz.